Hey you guys, I'm Shelby.
I'm Anna.
And we're going to do what we do best. We're going to go over the quiz questions from the Conic Sections. Alrighty, now let's move on to question 1. Take it away, Anna.
Okay, the question reads, this equation is which of the following conic sections? Our equation is 2x squared minus 3y squared plus x plus 2y plus 6 equals 0.
Okay, here's your answer choices. A, parabola. B, hyperbola. C, ellipse. And D, circle. Alright, so what you're going to need in order to solve this equation is to know the properties of each equation of conic section. So let's get started. Alright, so a parabola. In a parabola, there is going to be one variable that is squared and one variable that isn't. So, like this. See? You have x squared plus y or y squared plus x. One is squared and one is not. Okay?
A hyperbola has both terms squared, but they have different coefficients and they have different signs. So it can look like this. Or notice how they have different signs. The x is negative here, and then the y is positive, but then on the other side, the x is positive and the y is negative. And they have different coefficients.
Okay. For an ellipse, you're going to need the same signs, but you have different coefficients and both are squared. So, just like this. Or okay, as you can see from these, there are different coefficients. So this one is for x is 2 and this one for y is 5. But they have the same sign. Both are positive. And you can see same on this one.
Finally, we have a circle. A circle, both the squared terms have the same coefficient and they have to have the same sign. For example, sorry. Or here, both terms are positive and they both have a coefficient of 2. And on the other side, both are negative and they have a coefficient of 3.
Alright, so let's look at these properties and see which one matches up with the equation. Let's go with the parabola. Well, actually, let's just go to the equation. So, what is some of the properties of this equation, Anna?
So, as we can see, they both have squared terms. Okay, and they have different coefficients in front of each term. For example, the x has a 2 and the y has a 3. Finally, we can see that they have different signs as well. The x is positive and the y is negative.
So, which one matches up with which? Put your thinking caps on. What do you think, Anna?
Well, I can see from the characteristics that they have squared terms, therefore it cannot be A because there's one squared term missing. So, we can cross that out.
Let's take a look at B. They have different signs.
Check.
they have different coefficients.
Check.
And they both have square terms.
Oh, check.
But wait, let's check the other ones just to make sure.
So we'll put a question mark by B with the smileys. Next, we have an ellipse. So we can see that an ellipse has two square terms.
Check.
Looks like it has it. It has different coefficients,
Check.
but they have the same signs.
Oh man.
So it can't be
That
C.
one.
So we'll just cross this one out.
Alright. And finally, we're going to move on to our circles. Now the properties of this one, they have the same coefficients.
Wrong.
Well, it can't be these.
So
What are we left with?
B. So our answer is B.
Yay!
Good job, everybody.
Alright, now let's move on. Alright, question number 2. What is the A and B of this graph?
Is it A equals 6, and B equals 10? B, A equals 10, B equals 6? C, A equals 3, and B equals 5? Or D, A equals 5, and B equals 3?
Alright, so let's get started. First off, I think we're going to need to identify this graph, Anna.
So, is it a circle?
But Anna, it's not even on both sides.
Is it a parabola?
But Anna, I thought a parabola just had one half.
Is it a hyperbola?
Anna, I thought a hyperbola was two parabolas.
Then it must be an ellipse.
That's what it is. It's an ellipse.
Okay. So, let's look at the question. A and B. What is an A and B? Well, I think it's asking for your major and minor axis.
I think so too. So, is your A the major or is your A the minor axis?
Well, I think it's the major. What do you think?
I do too, Anna. So,
Okay.
let's see. We're going to label this the major.
So that means our y must be our our y must be our minor, which is our b. So A is x, b is y.
Alright. Now that we have our major and minor and we know what A and B is, let's see. Anna, is A going straight across or just half?
It's going half.
It's just going half. So, I guess that would mean that these two would be out because, that would be 10 and that would be 6. But it's not going straight across.
So this means that.
A and B are not the correct answer.
Oh, okay.
Alright, now let's see. We've already identified our major as A and our minor as B. So that means A has to be 1, 2, 3, 4, 5. And B has to be 1, 2, 3.
So that just leaves us with.
B.
Whoops.
Yay! Alright, let's move on to question 3. Alright, now let's start with question 3.
Okay, the question reads, write the equation, the working form, for the circle shown below if it is shifted 3 units right and 4 units up.
Alright, this graph, now let's Let's know that all the measurements aren't accurate here. Okay. Alright. Good
So,
graph though.
Nice circle, Shelby.
Thanks, Anna.
Okay.
Alright.
So the first thing we need to do is identify the graph. The question says it's a circle, so I'm guessing it's a circle, guys.
Oh, smart.
We gotta underline the important information.
Underline important information.
Okay, so what other things should we underline, Shelby?
Maybe the 3 units, right?
Okay, so 3 units, right?
And I was thinking the 4 units up.
Are you sure?
I don't know.
I guess. Okay. So, next.
Next, we have to identify the vertices of this circle. The bad circle, but it's still a circle. Alright, so, as we know, circles have the same distance to the center of the circle. So in this case, that would mean that the circle is at 0, 0.
So the vertex is
Right there.
0, 0.
Alright, but we're not using this graph, Anna. What graph are we using?
That one.
Yes. Yes, we are. So, where would the vertice be in that graph?
Okay, so you're telling me that this vertice has to shift 3 units to the right. So this way?
No.
Are you sure? Okay, this way.
Yes.
So 1, 2, 3.
1, 2, 3.
Shall we draw it here or do we do another graph?
Which one do you want to do?
Okay. So we'll just draw another graph.
Yeah, we can just draw another graph. 1, 2, 3.
Stop in my mind.
Alright, so the graph shifts 3 units to the right. So let's go from your vertex.
So we're at 0, 0, so plus 3 will be at 0, 3.
0, 3, right? And then you're going to shift 4 units up.
And then 4 units up, which will bring us here.
Alrighty, ladies and gentlemen, we have discovered the new vertex of our circle. And this is what we're going to need to solve the problem. Okay, Anna, so what we need now is the equation for the circle.
So that would be x minus h squared, parentheses, y minus k squared equals 0. So that's our working equation for a circle. So now we can just plug in our vertices. So our vertex now is at 3 and 4. So our 3 is our x, so we would replace that for our h. And then our k is 4. So what's our radius though? Our radius does not change from here to here. Only our vertex does. So in the standard circle, there was a radius of 5. So we'll still remain with the radius of 5. So x minus 3 squared plus y minus 4 squared will equal 5 squared. And that's our equation.
Alrighty. Question 4. Hey guys.
Question 4.
Question 4.
Final
And
question.
it says, what is the vertex of this equation?
the equation is y equals x squared plus 12x plus 32. We see there's only one squared term, so it's a
Parabola!
you
It looks like that. It's like a parabola.
just right parabola.
Okay. Alright. You have to be something new all the time.
So how will we ever find the vertex of such complicated equation?
Isn't there that one thing that Miss Rose said? Wasn't it like a vertex formula or something?
Oh yeah, you're right.
What
What's
was
it
that?
again?
What was that again?
I think it was negative b over
2A. That's right.
Oh,
Over 2A.
alright,
That's what
alright.
it was. That's what it was. Okay. Okay.
Well, what's our a, what's our b, and what's our c?
Oh snap. I think somebody told me that the square term was always gonna be your A, and whatever the coefficient was your A.
Alright, a.
And the C, I know the C is the one without the variables.
So I guess that's the b.
I guess that's
now.
B. That's I guess B.
Yeah,
Alright.
Okay. So a, b, and c. So let's just plug it into our formula.
Alright, so negative B, so we put a negative
12.
12. Okay, over 2, 1. So really, that would be negative 12 over 2, which equals
6?
6.
Oh, negative 6.
Negative. How you gonna be my sister, Anna? You don't even. Negative 6.
Okay, so we found our x, but how do we find our y?
Oh snap.
Come on, how are you going to be my teacher? You don't even know. So we'll plug in our x back into our equation,
Okay.
which would be,
What's that gonna be?
it's going to be negative 6 squared plus 12 times negative 6 plus 32. So now we solve.
Alrighty, let's get down. So negative 6 squared equals what?
36?
I think so. It wouldn't be a
Okay.
negative 36, would it?
No.
Oh, okay.
So what's 12 times negative 6?
I think, that's negative 72. Negative 72. That's what it is.
And finally we just add 32.
Just add 32.
So now we subtract
Now subtract.
and add.
Okay, so what's 36 minus 72?
Negative 36.
Negative 36. Okay. So we have negative 36 plus 32.
And that would be
Negative 4.
negative 4.
Negative.
Not positive. Negative.
So now we have our y.
Oh, y.
Y. And our x. So, what's our final answer, Annie?
I would say our final answer is negative 6, negative 4 is the vertex for y equals x squared plus 12x plus 32.
Bam. Alright, thank you guys. Thanks for watching our video.
Thank you.
Y'all want to encore, y'all just hit me up, you know what I'm saying?
Got my number.
Alright, we'll see you later.